Hey everyone, and welcome to today's Explainer. If you are sitting for the Cambridge Computer Science exams, and yeah, I'm talking about syllabus codes 0417, 0478, 0984, 0983, 2210, or that advanced 9618 AS and A level, then listen up, because you are in the exact right place. Let's dive straight in. Today we're going to completely deconstruct how to build bulletproof arguments, and, more importantly, how to absolutely master string manipulation functions. And look, mastering this is absolutely crucial, because this specific topic, it appears in literally every single examination series. Seriously, you cannot escape it. So rather than avoiding it, we are going to conquer it together. I'm going to show you exactly what the examiners are actually looking for, how to structure your answers so they practically grade themselves, and how to stress test your evidence so you can walk into that exam room with total unbreakable confidence.
So let me ask you something. Why do students consistently find multi-step calculations and method marks so incredibly hard? I mean, it's a phenomenon we see year after year, right there in the principal examiner reports. String manipulation isn't just about knowing what a substring or concatenate command does in isolation. Anyone can memorize that. It's about combining those tools in a multi-step algorithmic sequence. You see, when a question asks you to parse a string, extract a binary representation, perform a calculation, and then output a result, students just freeze. They totally lock up. They either try to just write the final answer down immediately, which misses all those vital, juicy method marks, or they get completely tangled up in the logic of their own algorithm. This single topic causes a massive bleed of easy marks, and today we are going to completely patch up that leak once and for all.
All right, really quickly, here is our playbook for today. We'll start with the exam survival hook, move into strategy and core foundations, do a method mark transformation, jump into a rapid-fire interactive workshop, and finish up with top examiner warnings.
Okay, Section 1, the challenge. Let's set the stage with a dynamic comparison between two typical computer science students who are facing a complex string manipulation question.
Picture this. On the left side, we have Alex. Now, Alex is that person who has literally memorized the entire textbook. When asked to evaluate an algorithm, Alex writes this massive, sprawling wall of text detailing every single string function imaginable, how length works, how mid works, what ASCII values are. It's just an absolute overload of raw computer science facts. But here's the problem. There is zero critical analysis. Alex hasn't actually evaluated anything. Then, on the right side, we have Sam. Sam is always racing against the clock, rushes the answer, writes a quick single line of pseudocode, and completely misses the command word requirement. The question specifically said evaluate, but Sam just gave a brief identify response. So what's the result? Both of these students fail the question. Their papers are covered in red pen marks, an absolute grading bloodbath, because they completely ignored the assessment objectives. They simply didn't understand the rules of the game they were playing.
To avoid the fate of Alex and Sam, we really have to look under the hood of the syllabus. You see, the assessment objectives for string manipulation functions target very distinct cognitive domains. We're talking about knowledge and understanding, application, and analysis. Think of it like shifting gears in a car. When the examiner writes a question, they are testing a specific domain. If they want application, they want to see you actually trace the string array and physically apply the slicing method step by step. If they want analysis, they want you to look at a piece of code that parses a string and explain exactly why it might fail on certain unexpected data inputs. Your string manipulation skills rely heavily on precise definitions, causal relationships, and integration. Top-performing students exhibit this deeply connected conceptual understanding that easily transfers to unfamiliar contexts. You just have to know which domain you're operating in at all times.
Section 2, the strategy reveal. Let's unlock the core methodology that top-scoring candidates use to absolutely guarantee marks. Okay, here is the secret weapon, the Peel framework. Point, evidence, explanation, link. Now, I know what you're thinking. Isn't that just for essay writing? No way. It is a lethal weapon in computer science when you're dealing with extended response questions or complex algorithmic analysis. Let's say you're asked to justify why an iterative loop is best for a specific string manipulation task. You don't just say, oh, because it's faster. No, you make your point. A for loop is optimal for iterating through this string. Then you provide hard evidence, because the exact length of the string is predetermined using the length function. Next comes the explanation. This ensures every single character is checked without risking an index out-of-bounds error. And finally, you link it all back. Therefore, the systematic processing of the string is memory efficient and highly robust. Look at literally any A-star past paper answer, and I guarantee you will spot this exact framework structuring their arguments perfectly.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Moving right along to Section 3, the transformation. Let's talk about how to turn those painful red pen marks into beautiful green check marks.
Systematic processing within string manipulation functions follows this precise, standardized sequence. I want you to think of this as a visual story method for your algorithms. You're walking the examiner through your brain. Step 1, identify key elements. Ask yourself, what exactly is the input string? What are my variables? Step 2, apply relevant principles. Are we converting a string to an integer, extracting binary data, or maybe searching for a specific substring? Step 3, execute the analysis with crystal clear, step-by-step working. Step 4, verify your results. Did you trace your algorithm with some dummy data just to see if it actually works? And Step 5, present your findings in the exact format requested by the command word. Listen, when you make your algorithms and string manipulations flow chronologically like this, you lock in those method marks. Even if your final mathematical output has a tiny, silly error, the examiner sees your unshakable logic and awards you the vast majority of the points anyway.
Stop scrolling. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
All right, Section 4, Interactive Workshop. It is time to put this into practice under a bit of time pressure. Let's see what you've got.
Welcome to Challenge 1, the data scan. Imagine you're in the exam hall. You've got 60 seconds on the clock. First, you must deconstruct the question. What specific string pattern are you actually looking for in this mess of data? Second, you need to extract the relevant binary data from all the background noise. Third, select your analytical framework immediately. Are you using a linear search algorithm right through the string array? Are you slicing the first 8 bits? Look, data interpretation skills in string manipulation are absolutely critical. You have to be able to look at raw binary representations, perform the calculations in your head, and draw evidence-based conclusions incredibly quickly. Time is ticking. You need to practice looking at raw data and instantly seeing the exact string functions required to manipulate it.
Okay, time's up. Moving to Challenge 2, find the flaw. I'm going to read a flawed sample paragraph from a student attempting a comparative analysis. Ready? Algorithm A uses a mid function, but algorithm B uses an array. Okay, what is the flaw there? Think about it. The flaw is the total lack of proper comparative execution and evidence. To get top marks here, you must identify similarities and differences clearly. You must use connectives like whereas, in contrast, or similarly. And crucially, you have to support each and every claim. A perfect execution sounds more like this. Algorithm A directly extracts the substring using the mid function, whereas algorithm B requires iterating through a character array, which increases time complexity. Do you see the difference there? We are connecting the core string concept directly to its real-world performance outcome. And now for our final workshop, Challenge 3, Speed Writing. You have 30 seconds to mentally draft one perfect PL paragraph explaining why data validation on an input string is strictly necessary. Ready? Go. Okay, here's how it should look. Point. Validation prevents catastrophic system crashes. Evidence. A string input exceeding the database field length causes a buffer overflow. Explanation. By utilizing the length function prior to database insertion, the program can automatically reject invalid entries. Link. This ensures overall system robustness and complete data integrity. Boom. Just like that. Clear notation, 100% correct terminology, and beautiful multi-step logic. That, my friends, is exactly how you dominate extended responses in computer science. Section 5. Critical Analysis. Let's pull back the curtain on the biggest pitfalls straight from the Cambridge Principal Examiner reports.
Let's be real. Top candidates demonstrate true mastery through evaluative thinking. It is not enough to just write a string manipulation algorithm that basically works. That's the bare minimum. You must demonstrate that you've considered multiple solutions. Could this be done with a regular expression instead of a clunky nested loop? You must analyze the algorithmic trade-offs. What is the time complexity versus the space complexity here?
If you create 3 entirely new strings during your manipulation process, your space complexity shoots up. Is that a problem for the specific system described in the question? You must acknowledge those limitations and justify your decisions with hard, undeniable evidence. This high-level critical analysis is exactly what separates an average coder from an exceptional A-star computer science candidate.
Now, I need to vigorously warn you about these 3 critical mistakes that constantly, and I mean constantly, rob students of easy marks. Number 1. Forgetting to check overflow and edge cases in string manipulation functions. What happens if the input string is just totally empty? Will your entire code crash? Probably. Number 2. Ignoring boundary conditions. The classic off by 1 error. If your string is 10 characters long and your loop runs from 1 to 11, you are going to get an out-of-bounds error and lose those marks. Number 3. Answers lacking specific question context. If the exam question is about a hospital's medical string database, your answer cannot just be some generic textbook code. It must explicitly reference the patient ID string or the specific medical data context provided.
Massive red flag here, guys. Examiner alert. The principal examiner reports reveal that candidates consistently confuse their key terminology. You absolutely must always define your terms before using them in extended responses. Don't just casually toss the word concatenate into a sentence and assume the examiner will generously give you the credit. No. Define that you are joining 2 distinct string data types together to form a single continuous string. Confusing key terminology, like mixing up an array index with a string length variable, will instantly derail your entire argument, and it will cost you the whole question. Clarity is your absolute best friend here.
Section 6. The final system. Let's consolidate everything we've learned into your ultimate computer science success blueprint.
Okay, here it is, the definitive answering system. The 3 golden rules. Rule 1. Command word decoding. Always start by identifying if the question is asking you to state, describe, explain, or evaluate. This one word dictates your entire approach. Rule 2. Peel framework application. For literally any extended answer, structure it rigidly with point, evidence, explanation, and link. Don't deviate. Rule 3. The time management matrix. Allocate your exam time strictly based on the marks available. Please do not spend 15 minutes writing a ridiculously complex string slicing algorithm for a 2-mark question. Deconstruct the question, extract the data, select the framework, and execute.
Students who implement these computer science strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos.
Here's your final reminder. Subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams. Your Cambridge success starts here.